We're now ready to use Pythagoras' theorem to find a hypotenuse. Now we're doing this first because it's slightly easier to find the hypotenuse, or C, than it is to find one of the other two sides. We'll learn that next. Alright, so the things we need to know. We need to know Pythagoras' theorem off by heart. So the first thing that we write, every single question we do, is we start with it. That way you're writing it down at the beginning of every question. After a while it becomes real habit and you know the theorem. The other thing to remember is always we use C as the hypotenuse. That's the long side and it's the one that's opposite the right angle. The other thing to remember is you can only use this theorem if you actually have a right angle in your triangle. So if there's no right angle there, it's a trick question and you can't use this theorem to find any of the sides. Alright, so here's the steps that we're going to use to find the hypotenuse in a range of questions. And I've got an example over here so we can follow through these steps and see how it works. Now here, this example says find x, and x clearly here is the hypotenuse, it's the long side. And we have two other sides, 4 and 5. Let's give them units as well. Now you might be tempted to think, hey, that's a 3, 4, 5 triangle, we've already looked at that one. But it's not, is it? How can you tell? Well, in a 3, 4, 5 triangle, 5 is the length of the long side, and here, 5 is one of the short sides. So it's not a 3, 4, 5 triangle, and this is not 3 centimetres long. Alright, first thing to do is write the theorem. Now, a squared plus b squared equals c squared. We'll write it like that every single time. Now, second step is think about which one is the c. The c here is our x, okay? So that means the a and b must be the other two sides. So the second step is sub in the values you know. Alright, we know 4 and 5, they're going to be a and b. Doesn't make any difference which way around they go because we're just adding the square of them together and it will be the same either way. So we sub in 4 squared plus 5 squared equals, now c squared, that's just going to be x squared. So we've subbed it in for the letter that we've been given. Alright, what's 4 squared? 16. What's 5 squared? 25. So it's handy in this step just to put the values in. Now at this stage, see how an equation is a little bit like a seesaw with the equal sign being the pivot? If you want to write the x squared on this side and the 16 plus 25 on that side, at any point here you could switch them over, okay? And you might like to do that from the beginning. You could have written c squared equals a squared plus b squared. That would be completely fine. I prefer to write it like that every time, and then somewhere on my way down here I'll get everything to swap sides. Perhaps on the next line, if x squared equals 16 plus 25, and I can figure out that 16 and 25 is 41, then on the next line I might write it like this. X squared equals 41, and you can see that 41 is now over here. They've just switched sides. Alright, so sub in the values you know, we did that. Find the value of c squared. Well, we've actually come down and we've done that. How did we do it? Well, we just put in the values by squaring each of these numbers. That means multiplying them by themselves. And then we worked out what they added up to, and we wrote it down. So we've got c squared, but we don't yet know what c is. Now, if you know what something is when it's being squared, how do you undo that? What's the opposite of squaring something? You take the square root of it. Now, if I'm going to take the square root of this x squared so that it's not squared anymore, I've basically unsquared it, haven't I? That's what taking the square root is. It's unsquaring it. Now, if I'm going to unsquare or take the square root of this side, I have to do the same thing to the other side to keep it balanced. And that means I draw this square root bracket over my 41. Now at this point you'll be thinking, oh, 41 is not a square number. So to find the actual answer you'll need to reach for your calculator, hit the square root button, which is up here next to your fraction button, and then type in 41, and then hit the equals button, and you'll get 6.403, a whole heap of numbers there. Now let's find x. The question didn't actually ask. Let's say to 1 decimal place. So you'll need to round it off here. Now it's 6.40, so that rounds off as 6.4, and I need to include my units, centimetres, and if I've rounded it off, I need to say what I've rounded it off to. Now let's include that in our steps, because that would be nice to add so that we remember to do it every time. Include units, and if rounded off, state the level that you've rounded it off to. Okay, that's a nice way to finish off our set of instructions. Okay, let's have another quick example. We can undo this one and go again. All right, we'll leave this as x. And let's just give ourselves some other side lengths here. How about, I don't know, let's go for 92 and 87 meters. This is a big triangle now. All right, first thing we do, write Pythagoras' theorem. A squared plus b squared equals c squared. Next thing, sub in the values we know. These will be a and b. So we have 87 squared plus 92 squared equals x squared. What next? Well, I can't do 87 squared quickly and easily in my head. Two things I could do. I could come over to the side here and do 87 times 87 and work this out. But let's save time and use the equipment that we've got in our hand. 87, now I can either do 87 times 87, or you can just hit the squared button, okay? Now you could figure out 87 squared and actually write it down, okay? And then figure out 92 squared and write that down. And then on the next line, you could add those two big numbers up. But if you're reaching for your calculator, why not be efficient and put it in one go? Now to do that, you're going to hit 87, then hit the squared button, and then hit plus, and then 92, and then hit the squared button again, and make sure that what comes up on your screen is actually what you're wanting to find. Hit the equals button, and we've now done that whole step there in one go, and we can see the answer for it, 16033. So I'm going to do the side switch now. I'm going to write x squared is equal to 16033. All right, so I've found what my hypotenuse is when it's squared. So what is it when it isn't squared? Well, I have to take the square root of this side to unsquare it. So I need to take the square root of this. Now, if you've already got this in your calculator, a cheeky trick is you can hit the all clear, hit the square root button. Now, if I press this button down here that says ANS, that stands for answer, and if I hit that, the last answer my calculator had, which was 16,033, will go in there. Now, it just says answer, but that's what you'll get. Hit the equals button, and we've got the square root of that number, 126.6 meters. I'm including my units, and I've rounded it off, so I say what I've rounded it off to 1 decimal place. Now, if you want to be sure that answer trick works, go back, put square root of 16,033, and reassure yourself that that method works, and it saves you a little bit of time. Okay, I've added one more step. Step 6, check that your answer makes sense. Now, you should do this every single time you solve a maths problem, but it's especially important for one like this. Because we're dealing with square numbers and we're taking square roots, we're dealing with numbers that are really big and then get vastly smaller. So if you've made a mistake, your answer is usually wrong by a lot. So how do you check? Well, take your answer, in this case it was 126 and a bit, and think, would that make sense for this triangle with 87 and 92 meter sides, for this to be 126? And it does make sense, so I can be pretty sure I must have done it right.